Okay, we're going to go over some of the solutions to assignment 3. And in this first video, we're going to go through problems 13, 14, and 15. Problem 13. If you deposit $100,000 into an account that pays 10% per year, how much will the account be worth 5 years from today if interest is compounded A, annually, B, semi-annually, C, quarterly, and then D, monthly? Okay, we need to solve for the future value of present amount. The present value is going to be $100,000. The interest rate is 10% per year and N is 5 years, but that's only if you do it annually. So let's do that case first, very simple case. Future value is equal to the present value of $100,000 times 1 plus R. Since interest is compounded annually, we use 10% for R, and it'll compound for 5 years, and we get a future value of $161,051. Now in part B, interest is compounded semi-annually. So now what we need to do is we need to adjust the interest rate. We need to think of a period being 6 months in length with semi-annual compounding. So the interest rate has got to be per 6 months. Well, how many 6-month periods are there in a year? There's 2 of them. So take the annual rate divided by 2 to get 5% per semi-annual period. Take the number of years times 2. We need the number of semi-annual periods. So we'll take 1.05 to the 10th. And notice we get a little higher future value. Why? Because interest is paid sooner. We don't have to wait the full year. In part A, you have to wait a full year to get 10%. But in part B, you only have to wait 6 months to get 5%. And then over the second 6-month period, you're earning 5% on a greater amount that already included some interest being paid. So you get a greater compounding effect. But you see the general rule here. We'll follow this with part C and D. You take the annual rate, you divide by the number of periods per year with semi-annual 2. Take the number of years times the number of periods per year, and again, 2 for semi-annual. Okay, C, quarterly, and then D, monthly. With quarterly, we take 10% and divide by 4 quarters per year. The interest rate is 2.5% per quarter. With 5 years, there's 20 quarters, so it's 1.025 to the 20th. You get 163,861.64. And then with the monthly compounding, 10% divided by 12, get 0.83333. And there's a repeating 3%. 60 years. So you get 100,000 times 1.00. Don't forget to still divide this by 100. Yes, it's true that it's already a decimal, but it's a percentage. You got to convert that to a decimal by dividing by 100. So insert 2 zeros in front of the 8. It's 1.008333333, repeating to the 60th power, then times 100,000, and you get an even higher future value. Now, if you did this and got a number that's close but not the same, you probably introduce some rounding error. I'll show you a quick shortcut to not get that rounding error. On your calculator, type 10%, or just type 10, divide by 12, and you'll get 0.8333. Then press I per year in your calculator. Don't enter 0.8333 on your calculator. Then you're truncating it yourself, unless you keep hitting as many 3s as the calculator will hold. We'll simply take 10, divide by 12, equals, and then press the I per year key, then put in 60 for N, put in 100,000 for the present value, and then press the future value. Number 14. Lorraine borrowed $312,500 to buy a house. Her mortgage loan has a stated interest rate of 9%, pretty high for today's mortgage rates, which are around 4%. For a term of 30 years, compute her monthly mortgage payment. Well, the amount she borrowed is a present value. That's what has to be paid. The bank has paid the seller of the house that amount at closing or 3 days after closing. And then you've got to calculate the annuity that is equivalent over 30 years with monthly payments to that present value amount at an interest rate of 0.75% per month. You've got to take the annual rate and put it on a monthly basis. You've got to take the number of years times 12. This problem must be done on a monthly basis. It would be incorrect. You'll get the wrong answer if you were to try to compute an annual payment and then just divide that by 12, because then you're ignoring the intra-year compounding effects. Okay, we use the present value of an annuity formula. The present value is known, $312,500. The annuity, the payment, is the unknown. 1 minus 1 over, again, don't forget, 0.75% must be converted to a decimal, so it's 1.0075, raise that to 3/60th. All of that divided by 0.0075. If you crunch through that, you get 2514 $2,514.45. But again, we just go to the calculator, right? Press gold clear all, put in 360 for N, 0.75 for the interest rate per year, 312,500 for the present value, and hit payment. And then you get that answer that was on the previous slide. Number 15. You have $25,000 in an account that earns 9% per year compounded monthly. You plan to deposit an additional $5,000 at the end of each month for the next 10 years. Compute the future value of the account 10 years from today. So here's my time diagram. I got $25,000 in today, and we're going to put $5,000 per month in for the next 10 years, which is 120 months. They're both going into the account. So all we need to do is take the future value of the present amount for the $25,000, and then take the future value of the annuity with $5,000 as the annuity. Both must be done using the monthly rate and the number of months. So here's the first part. I'm taking the future value of the present value, and here I'm taking the future value of the annuity, with both parts done on a monthly basis. 25,000 times 1.0075 to the 1/20th, from time 0 out to month 120. And then the future value of the annuity, 5,000 times 1.0075 to the 1/20th minus 1 over 0.0075. That's taking the future value of every one of these payments, 1 through 120, monthly payments. And we get those future value amounts and we add them together and we get a future value of $1,028,855.31. On the financial calculator, you can do this in one step using the 5-key approach. Put in 120, press N, put in 0.75 I per year. Now both these are going to have the same sign, 25,000 present value, 5,000 annuity payment. Why? Because the 25,000 is in the account, 5,000 is going into the account. When we press the future value, we'll get a negative answer. It's representing the amount we could then take out of the account. Okay. You can also get that by looking at the equation. Look at the equation where you have everything additive. That's this first equation right here. Okay. What's on one side of the equation, the PV and the A will be one sign. What's on the other side of the equation will be a different sign. So we expect the present value and the annuity to be one sign. We enter those as positive. So we would expect the future value that we get when we press the future value key to be negative.